Okay, so welcome back, and now today we're going to start talking about differentials. So in a lot of cases we may be interested in determining the amount of change or measuring the amount of change in the function f of x. Okay, now in order to talk about that, let me further specify, it's in determining the amount of change in f of x when there's a small change in the independent variable x. Okay, so in those cases we have to talk about the concept of a differential. So let's start with this idea and go back to the Leibniz notation. Okay, so in Leibniz notation we had the dy dx, right? And there really was no, interpretation other than just the understanding that this represents a derivative, right? It's a notation. When we introduced it, all we introduced it as was a notation. So now what we're going to do is we're going to, in order to discuss more formally, we're going to need to define the concept of the differential. So differentials provide us with a way of estimating the amount of a function that a function changes as a result of a small change in the independent variable x. Okay, so now, so here's where we're going to see a meaning to the expressions dy and dx. Okay, so what we're going to do is we're going to let dx, let dx represent the change in, well, do I want to say it that way? Yeah, let's do that. Let dx be the independent variable. Okay. When there's a change that can be assigned to any non-zero real number. Okay, so let this be the independent variable that can be assigned any real number. Okay? Okay. Actually, no. Non-zero, right? We want a non-zero real number. Okay. And then we're going to define dy to be the following. It's going to be f prime of x times dx. And so dy is going to be the dependent variable that's going to be defined as follows, right? F prime of x dx. Okay. Now, it's important to notice that dy is a function of two things, x and dx. Okay? And we're also supposing that f of x is a differentiable function, by the way. Okay, so that's one of the other things that we want to assume. So assume f of x is differentiable. Okay? Now, the expressions dy and dx are called differentials. Okay, so now these two things are called differentials. We can go ahead and divide both sides by dx, and we get the differential expression that we were looking at before. So dy dx equals f prime of x, which is the notation that we're used to. Okay? And this is known as differential form. Okay? Of this equation. So these two are the same. Okay? But again, these are called differentials. Okay? So think of dy and dx as real small changes in x. So one of the things we want to see is, okay, if I have a really small change in x, what kind of change is that going to cause in y? So if I have this differential, what is this differential going to be at? So now we have some meaning that's attached to these differentials. Okay? So now, we're going to do an example and show you how this works, and then we'll go on. Okay?